In this video, I want to investigate a situation where we have holding cost. So we're going to have a scenario with a company that is processing units, and if they are not able to process units in a day, they actually hold over units till the next day. And if they hold over units the next day, they are charged a holding cost. So let's talk about this problem in a little bit more depth. We have a large-scale dry cleaning company, and we would like to investigate their holding costs over a 2-week period. The company has many contracts around town and pride themselves on a quick turnaround. However, in cases where they're not able to provide a same-day turnaround, they reduce the cost of processing the units that they must hold over until the next day. Holding cost per garment is $10, so essentially you can view this $10 as a loss of revenue. So anytime they're not able to process the number of units that they have scheduled in a given day, they're going to reduce the price by $10 to maintain high customer satisfaction. The company schedules its operations over a 2-week horizon and would like to develop a spreadsheet to investigate this situation further. Okay, in terms of the company has this reliable machine that they essentially load 75 garments on, and essentially would take a day to clean those 75 units. So it's a very static value, and they've had high success running 75 units at max per day. So we want to develop this spreadsheet in a dynamic fashion, of course, that'll calculate the total number of garments held in the 2-week planning horizon. We also want to calculate the lost revenue over the 2 weeks and a lost revenue per day. Assume the number of garments at the start is 0. The spreadsheet should be built in a fashion so that any 2-week schedule can be loaded and calculated. So let's go ahead and start this learning activity by opening up the starting file. Okay, when we open up the starting file, we see a template here. We have the input values in a table here, the output of this analysis here, and essentially a 2-week schedule, day 1 through day 14. And it looks like we have scheduled garments on these days, sometimes 0, sometimes minimum it looks like 50, upwards of 100. So essentially we have these other columns that we'll need to develop formulas for that'll look at the scheduled situation and be able to calculate the things that we need. So we have a cell here, the Q at the start of the day. We were told in the problem that the starting Q is actually set to 0, but we want to make this dynamic in fashion. So we're going to actually use this as an input. Number of garments to start, we will call 0. And while we're at it, let's go ahead and fill the rest of the information in. The max garments that can be processed per day was 75. The number of days in the simulation is going to be equal to 14, but rather than just simply referencing 14, what I want to do is actually count the rows. So I'm going to use the rows formula and simply highlight the number of rows, which of course will be 14. Just in case in the future that we want to either subtract or add rows to our calculator, if you will. The holding cost per garment is going to be $10, and that's already formatted as a currency value. Again, we have the schedule here, and we have to incorporate the logic within all of these cells that will reference these garments. So, for example, some cases we won't have any Q at the end of the day because we'll be able to process everything that was scheduled. In other cases, for example, day 2, we're scheduled to do 100, and we know going in that we're going to actually have some held at the end of the day. Okay, the number of garments processed. Well, we also need to calculate an adjusted or a value for the actual number of garments processed. We have a column for the number of garments processed, or this is the column that represents what's actually there at the store ready to be cleaned, not necessarily how many actually got cleaned. That would be reserved for the next column, the actual garments cleaned. For example, we could have 100 that needs cleaned and we're only able to clean 75 of those, so that logic will go here. The Q at the end of the day is anything that is left over once we've hit our max. The output table, we have the total number of garments held, the lost revenue in terms of a total, and then an average lost profit per day. Okay, so let's go ahead and start thinking about this template and the things that we need to reference. The first thing we were given in the table is that we have to start this simulation, if you will, with 0 units. And of course, we want to do this in a dynamic fashion because it could be a situation where this company wants to use this spreadsheet and potentially has some units on hand that need to be processed. So actually, this cell is going to be referenced in a dynamic way to the number of garments to start this 2-week planning horizon. I'm going to reference B2 there and hit enter. Now let's think about how we're going to develop this spreadsheet. We're going to develop this spreadsheet in a way that we can't simply fill this formula down. What we actually want to do here is reference the Q at the end of the day. So for day 2, the number of Q at the start of the day will be equal to the Q at the end of day 1. So we'll make that reference and in the row above and hit equals and fill this formula down. Okay, this logic will be good, of course, for all these calculations. The only difference in this column was that we had to start with a value in the table for the first calculated cell, but then anything else will be actually we'll be able to reference that in column F, Q at the end of the day. Okay, in terms of the garments being processed, this is actually the needed column. This is going to be a sum of the scheduled, so we have 50 scheduled for day 1, plus any Q at the start. And I didn't necessarily mean that plus. We can do this anyway with the sum or the plus sign. Let's just keep it easy and do this style. So B9 plus C9. And this will actually be the formula for all the remaining cells. So now it comes to a situation where we actually need to think about our logic pretty seriously. So in this situation, we really have 2 numbers that are possible. One is either going to be the maximum value of 75, and the other value will be anything less than 75 that we happen to need processed. Okay, so what I would actually do to start this process is actually just take a difference. So let's take a difference of 75, which is the maximum, minus the number of garments being processed. In this situation, we have 25, which indicates to me that we actually are okay. We have an excess of 25 units that we could potentially process. Let's fill this formula down. And we see several situations where we have a negative sign. Okay, for example, row number 2. We actually can only process 75, but we needed to process 100. So essentially what this is telling me is that if this is equal to or less than 0, we're in a situation where we're over our capacity. So we can utilize that information in a way to calculate the actual garments being cleaned. So let's use an if. So if this difference is going to be actually above or equal to 0, then we can actually process what we wanted to process here in D9. If that's not the case, and we have a false condition, we're in a situation where we actually don't have the capacity to process, at which point we'll actually be able to only process the maximum garments per day. So let's go ahead and reference B3 in this situation and use our $sign. So this logic is a bit difficult to grasp at first. So I'd recommend if you actually go through this a few times and think about the logic on your own to generate these numbers. Certainly there are other strategies that can be employed to calculate these. Additional ways of performing the check, the conditional portion of the if statement, you might want to investigate. But I think this is one of the better, more simplistic ways of doing this. But that's just my opinion, of course. You might think of something that's far easier and more simplistic. Okay, so this is really representing a situation of the actual number of garments. So what we actually have to do now is account for situations where we have a queue at the end of the day. So in a similar fashion, we really only have two situations to investigate. One, we're going to have zero queue, and the other one will have some sort of value that represents what we have queued at the end of the day. To do this check, I would recommend doing another difference. Let's check the situation if, now here, if E, which is the actual garments, if E represents less than D9, which is the number of garments to be processed, we have a situation where we are actually going to carry that inventory. So if the actual garments processed is less than what was actually required or scheduled to be processed, then we sort of have an issue. And if we have this issue where we need to carry over, the difference will be equal to the number of garments per day minus the actual ones that we can process, comma, if this is false, we don't have a situation where we need to carry that inventory, if you want to call it that, over this number of garments, so we'll be left with a 0. Let's put our ending parenthesis there and hit enter. So let's walk step by step before I fill this down. This situation, we start with 0, but we have 50 scheduled. The queue at the start, of course, is 0, so our adjusted number of garments to process will be 50. We can process actually all of the 50 units since our max garments per day is 75. So we're in a situation where we don't have to carry over anything, so we're not actually losing any potential revenue stream. Let's fill this down 1. We have 100 scheduled. From the previous day, we know we have 0 being processed. So the total adjusted value, if you will be the 100. We can only process 75 due to our machine capabilities, which will leave 25 remainder. Once you're satisfied with validating this logic, you might want to walk through a couple more, and I'll just do one more before I fill this formula down. We have 0 scheduled on day 3, but we had the 25 left over from the day before. The total adjusted would be 25. We can process all that no problem, which means we're not going to carry anything over. So once you're actually comfortable with this formula, go ahead and fill this down. And we have all of the information we need to summarize this problem. So they are investigating the total number of garments held. Maybe they're looking at some statistics to purchase a new machine. So if the lost revenue is actually above what it turns out to be a cost for a new machine per day, maybe they'd like to invest in that new machine. Of course, if they're not losing that much money, it's probably not going to be advantageous to buy a new machine. But let's keep the scope of this activity limited to just the problem at hand. So the total number of garments will just simply be a sum of everything in the table above. And it does appear that we have 100 garments that we were holding at one time or another. So what would be the lost revenue? Well, we simply have the $10 holding cost, which again could be thought of as the lost revenue per day, times the value above. I'm just going to reference G25, it looks like, and hit the arrow key over to reference the cell above. So we've lost about Well, exactly $1,000. Well, what about the lost profit per day on average? Well, it's going to be the $1,000 that we're losing in the total number of days divided by the total number of days, which actually we can reference here in the table, 14. Let's hit enter. And it seems that we're losing a potential of $71.43 a day based on this particular schedule, which again might change from every 2-week planning horizon. So just to recap on some of the logic that we implemented, we created an input table which had all of our values that we might want to change. For example, maybe we increase the holding cost from 10 to 15, and that's going to be built into this table where it influences the output. Let's hit undo to get it back. Of course, we can change our processing limit. Perhaps we have a problem with the machine and our processing capability goes down to 60 garments. Well, of course, that logic is going to be referencing these values so we can actually take care of all this schedule and we can quickly calculate the lost revenue, lost profit. Actually, this should be, while I'm thinking about it, it's not necessarily profit, it's lost revenue. So I apologize for that. But anyway, the idea is that we can change these in a dynamic fashion and all the logic is incorporated. We then calculated the start of a day. We referenced the value here that told us how many units we had carried over from, let's say, day 0 or the previous day. We then referenced the queue at the end of the day for the prior day, the units that we couldn't actually process the prior day, the number of garments that needed processed here, which will be simply a sum of the scheduled plus the queue. And then we needed to write some logic in order to determine the actual garments that got cleaned. So that took a little bit of logic in terms of identifying situations where we actually needed a situation where we could only process the max or actually the difference. Finally, we calculated the queue at the end of the day, which again required some logic. We're essentially comparing the actual garments to the ones that needed processed, and if that difference, or if the actual was less than the number needed processed, we actually have the difference here to calculate the number of units being queued. Or if that difference was not met, or that condition was not met, we have 0 in the queue. Summarizing here, we just simply summarize the total number of garments being processed, the lost revenue total, and then an average daily value.